Hello, I'd like to welcome everyone to today's webinar on fire blight control in organic pome fruit systems under the proposed non-antibiotic standard by Ken Johnson of Oregon State University in Corvallis, Oregon. My name is Alice Formiga, and I'm the webinar coordinator for eOrganic. eOrganic is the organic agriculture community of practice with eExtension. We're a community of cooperative extension service personnel, researchers, ag professionals, organic certifiers, and practitioners. You can find all of our published articles, videos, and our many other recorded webinars on organic farming topics on our website at extension.org/organic_production. Before we begin, I'd like to briefly introduce our speaker, Dr. Ken Johnson. Ken is a professor of plant pathology at Oregon State University in Corvallis, Oregon. At OSU, he teaches plant pathology, and he has researched fire blight control for over 20 years.
Thank you, Alice. This is Ken Johnson, and this is my first webinar, so I'm sitting in a little room and talking to a computer, so it's a little bit different than getting up and giving a talk at a meeting or something like that. And I should say something about this slide here they got of me talking. This was up in Hood River a few years ago on a field trip, and you can see that from the reactions of Steve Castanoli and Debbie Breath in the back, they're kind of puzzled at what I have to say. So hopefully that message doesn't come through today, and it comes through loud and clear. But we'll get started here. So we're talking about organic systems, and so the talk is primarily about organic systems. And though everything I have to say relates to control in conventional systems as well, other than in conventional systems we can still use antibiotics, and I fully expect that we'll be able to continue to use antibiotics. In organic systems here, the situation has gotten a little bit different, in that the fact that we may lose antibiotics from organic production here in the next couple of years. And I don't, if anybody that's been paying attention to the news the last couple of weeks, you heard that there was an organic equivalency standard set between EU and U.S. And one of the bones of contention in the final agreement was the fact that we use antibiotics in pears and apples. And so there's that. And then prior to that, in last year, the National Organic Standards Board set new expirations for both streptomycin and oxytetracycline of 2014. So streptomycin and oxytetracycline are still allowable materials until through the season, the 2014 season. So that would be 3 seasons from now. And they may or may not go off depending on industry action to file a petition to try to prevent this from happening. But as of right now, there is an expiration set for streptomycin and oxytet in the organic program. So our research then has been trying to come up, what are we going to do if we lose antibiotics from organic production? So that's what this seminar is primarily about. So my focus is on floral infection and susceptible cultivars. And it's about susceptible cultivars because that is what the large percentage of the acreage is now in apples and pears that are grown organically. They're susceptible to fire blight, and they can get fire blight. So we're looking at practices that can prevent fire blight in susceptible cultivars. And I need to make a little caveat in that the strategies and the data shown are most applicable to the semi-arid production regions of the western United States, and that's because that's the systems that I work in, and that is the systems where we've received funding from growers in the region, and there's also a large number of organic acres in this area. What I'm not going to say very much about is host resistance. And of course, host resistance is the ideal solution to fire blight, but it's a longer-term goal to get fruit cultivars that are both resistant to fire blight and then meet the standards that are being demanded by consumers for quality and flavor characteristics, and et cetera. And the other thing I'm not going to say much about is the management of host susceptibility. This would be nutrition, things like that, nitrogen fertilization. These are all very strong interests of mine, but I just don't really have the time or space in this webinar to go into that into much detail. I would say that nutrition, management of nutrition is very important in fire blight control, though it only plays a part. You still get infection, and then once you've got an infection, nutrition plays a part in how much the disease runs through the tree. So that's sort of what the seminar is about, and then I guess we'll move on from there. All right, so I'm going to say some things about materials registered for organic fire blight control, and these things are going to pop up in the seminar. And so a lot of the work that we've been doing is related to how to use these materials most optimally or efficiently to get fire blight control. And most of you are probably aware of many of these materials, and some of these are biologicals, and then I guess they're all considered biologicals, where I got the category here, biologicals, which would be Blight-Bane A506, Bloomtime biological. Those are bacterial products, probably say gram-negative bacterial products at some point. Generally, as standalone products, they're only so-so in fire blight control. They can make a contribution, but they're not standalone. The other product that's going to be new this year that's out there, it's being distributed by Westbridge, is Blossom Protect, and this is a yeast product. And it has been, in our trials, a much better product for fire blight control, and we'll talk a little bit about how that material is used. And then finally, the other material here that is registered for organics presently or currently is Serenade Max, and we view Serenade Max as more of an antibiotic-like material, that the living organism in the bag isn't that important to control, but that the antimicrobial compounds made during the fermentation, just like you would make an antibiotic, are what's mostly contributing to control. So Serenade we consider antibiotic-like, whereas biologicals at the top we consider to be living organisms, and that they need to grow and I guess and prosper on the flower to have a contribution to fire blight control. There's a few other materials that are out there that with potential for organic control, and we don't know very much about them yet. And one of these is a resistance inducer. It's called Regalia. Regalia is an extract of giant knotweed, and it's not directly toxic to pathogens, but if you put it on a plant, it induces the plant to turn on defense genes, and by turning on defense genes, it makes the plant more resistant to fire blight infections. And there's just not a lot of data yet on how to use Regalia for fire blight, so I've just got a question mark about how it can be used. We're going to put it in trials this year and see what we can do with it. We think, again, it's probably not a standalone material, but that it should be integrated with some of these other products, and that's what our trials are going to be concerned with. The other materials that are out there on the horizon are these copper and organic acid products, and it's unclear at this point whether they'll get NOP approval, but other coppers have gotten NOP approval, so I think there's a good chance that they'll get approval. And the two materials are Phyton 27 AG, it's called. This is a food crop form of Phyton 27, which has actually been used in nursery industries for decades. And the other is this Gowan GWN 9979, which is also a copper and organic acid product. And Tim Smith at Wenatchee has been working with this product for a few years, and he's just been getting very good control with it of fire blight. The thing that's different about these products, these organic copper and organic acid products from regular, say, fixed copper products like copper hydroxide, is that the amount of copper in the product is much, much lower, and that the amount of pounds of copper that would be applied in a typical treatment is only, in the 5 to 10% range of, say, a 4 to 6 pound application of a fixed copper in the orchard. So because of that, there's so much less copper being used that they are actually fairly safe. And that's still a bit of a question mark, but Tim Smith's been doing a number of years, like I say, with multiple applications of this GWN 9979 and has not seen any fruit russeting from his treatment. So these things hold some promise that we'll have some copper in organic acids also available for non-antibiotic control of fire blight. Not going to say really anything more in this webinar about these products, just so that you know that they're out there. Okay. Just a little bit about the disease cycle. Everybody listening probably knows the disease cycle of fire blight, but just so everybody's on board with this, that everybody knows that that it overwinters in old cankers in diseased wood from last year. And so right along the margins of these cankers is where the cells will get active as the tree is waking up in the spring, and cells that start the epidemic then are located around these things. So orchard sanitation is extremely important in fire blight control, and the more of these old cankers you can get out of your orchard, the better off you are. From these old cankers, the pathogen makes a jump into the flowers, so now it has to start in the flowers and you really get going that way. So somehow it makes this jump. There's been a lot of ways that's been hypothesized to happen: rain and wind, flies visiting old cankers, and then they go visit a flower, etc. And once they get into the flower, it starts what we call the floral epiphytic phase. And so this is growth in the flower, primarily on the stigmas of the flower, and the stigma is the surface that the pollen lands on and germinates and fertilizes the flower. So the stigma is a very nutrient-rich habitat that supports pollen grains when they land, but it also supports bacterial growth when it lands as well. And so the bacteria really can multiply rapidly on stigmatic surfaces. And then when a bee comes and visits that flower and the bacteria has been growing on that stigma, it rubs onto the bee, and then the bee goes to the next flower, and it can spread the pathogen to the next flower and keep the cycle going. And so this floral epiphytic phase is where the pathogen now, it's not causing disease, but it's just growing on the flowers and building up. And this drives the amount of pathogen that's, cell pathogens, fire blight pathogen cells that are in the orchard that are available to cause infection. And when they get to a certain number on a stigma, they have to slide down the style into the floral cup or the nectary, and then they go in little openings, which are called the nectar throats. They're little natural openings in the base of the flower. They swim in there, and they start the infections. But this epiphytic phase is essential for building up the pathogen in the flowers, and then having enough cells in the flower so that there's enough of them to swim in those little openings. And this whole process is driven by temperature. So the speed at which this floral epiphytic phase can go around is essentially a function of temperature. When it's cold out, it just turns very, very slowly. And then if we get those days in spring when it gets up into 80, this thing is just going around like crazy. So that's what fire blight risk is about. And so if we look at the models that are out there, like cougar blight or Mary blight, or Brock Zoller has one down in California, they're mostly modeling the speed of the floral epiphytic phase, how fast they turn. They don't model the jump so much. And the only thing that, say, cougar blight would really say about the jump is what it would set a lower threshold depending on how close disease was last year. So if you had disease in the orchard last year, then the threshold for starting action based on cougar blight would be set lower. And what they're just saying is that the probability of a jump is much higher if disease was in the orchard last year than if it wasn't. All right, so that's the disease cycle. Just a little bit more about fire blight risk. And so I've got over here on the y-axis is a degree hour total, so heat unit total. It's a 4-day heat unit total. And this approximates how cougar blight works. Tim Smith has added a little bit of non-linearity to the way he accumulates heat units, but this is essentially a close approximation of cougar blight. And so that, say that the temperature for that hour was 80 degrees, and we're using a cutoff here of about 60 Fahrenheit or 15.5 Celsius. That would say that in that hour that we're at 80 degrees, we are 20 degrees Fahrenheit above the 60 Fahrenheit threshold. So we would have for that hour 20 degree hours, or 20 heat units above the threshold. So 80 minus 60 is 20 heat units above the threshold for that particular hour. And then you keep track of that total for every hour over the last 4 days. And then on the next day, the 5th day, the first day of the 4-day total falls off, and you add the next day. So that on warm spring days, when you're getting temperatures up into the up into the 70s and 80s, you can build fire blight risk really quickly. And remember that we're just talking about how fast this floral epiphytic phase turns. And as the temperature builds then, and the faster this thing goes, we are getting into moderate risk and high risk and extreme risk and so on. And it used to be, back when streptomycin, at least for us on the West Coast, was effective, that we could sort of ignore this whole pathogen buildup phase. This is the pathogen buildup phase. We could ignore that. We could come in with streptomycin at fairly high levels of risk, and because it was such a good product for killing bacteria, we could get good control. And so we would say, all right, we're going to put on a treatment when we hit high risk, and we maybe put on another one if it keeps going, and we get good control. Well, of course, we got resistance to streptomycin, and we had to go to another tactic. And the next tactic was to use oxytetracycline. Well, oxytetracycline didn't work quite as well as streptomycin. And we found over the years, working with Virginia Stockwell, who's also here in Corvallis, that if we put on a biological treatment early on, this would be one of these gram-negative bacteria products like Blight Ban A506 or Bloomtime Biological, and then went to using Oxytet at these later stages of bloom, at these higher risk times, we could also get very good control. So we called this integrated control, and this idea is going to kind of pop up again and again as we go through this talk here. And finally, now that we're talking about non-antibiotic control and for the products we have, I think one take-home message of this is that if we're going to use non-antibiotic control successfully, is that we're going to have to work more on the pathogen buildup phase with products. And it's probably going to take a couple more applications of materials in order to get good control. Though as we go through this, I think you'll see that getting good control is going to be possible, though, as I say, it's going to take a couple more treatments. It could be as simple as using bloom thinners, lime sulfur bloom thinners for apples at these earlier stages, and we're doing active research on that, but we think that bloom thinning with lime sulfur is a pretty good fire blight control product for these early stages of bloom and slows down this pathogen buildup phase. So we'll come back to that. All right. So the grant that we have, Rachel Elkins and Tim Smith and I have with the Organic Research and Extension Initiative, is to apply a systems approach to non-antibiotic control. And we've been working on this now for a couple of years. The grant is just starting, but we've actually had research going on in this now for a couple of years. And so we've got 4 questions that we've been trying to answer, doing active research on most recently. And the first one is when is the fire blight pathogen active in orchards, or maybe I should say, when is the fire blight pathogen detectable in orchards? Or can we find it? When is it actually doing its thing in its flowers? The second one we've been working on is, does delayed dormant copper affect pathogen activity? This is an old question, as everybody knows. It's a really old question in fire blight control, and we've been trying to figure out what delayed dormant copper really does, and I think we have some interesting results on that.
All right, so we're at this question, is the pathogen active in this bag of flowers? And so we've been developing a molecular test that can give us an answer pretty quickly, in about an hour. And so the way this little test works is that we would take a little bit of water, we would take a wash of these flowers in the bag, and we do this with a molecular technique called LAMP. And by doing this LAMP in there, we specifically look for the DNA of the fire blight pathogen, and if it gives a reaction in the tube, and if it gives us a negative, we don't see anything at all. So we've been taking this technique to orchards and basically putting it into an IPM mode, or scouting mode. And so the technique here has been to collect about 100 flower clusters per walk, which is about 600 flowers, and do 5 walks per hour per orchard. And we've been sampling these orchards at mid, full, and petal fall. So each of these blue arrows currently is a bag of flowers. So a bag of flowers has about 600 flowers in it. And so each of these blue arrows here, we do a LAMP assay on. And so what we're doing here is that we've been, we're trying to, follow this process, the process of the floral epiphytic phase and the buildup of the pathogen in flowers. And so we've done, between 2008 and 2010, 2011, we did about 100 orchards. And the overall probability of finding the fire blight pathogen in one of those bags of flowers was 15%, about an average of 15%. At mid-bloom, we found it in about 9% of the blue arrows, and at petal fall, we found it in a third of the blue arrows. So you can see that during the bloom process that this little circle is going around, the fluoroepiphytic phase is building the pathogen, and that the pathogen starts out at a fairly low level of detectability early in bloom, and then goes to a high level, much easier level of detectability by late in bloom. And so this is just some data from some of the orchards we've looked at. So we've been in Washington, California, Oregon. We've been in Utah places, and we've been collecting up these samples. We subject them to LAMP assay, and so the numbers here are where those probabilities on the last slide come from. So this is 11 of 122 early bloom samples were positive, and as we get out to petal fall, then we can see 27 of 112 in this data set were positive. And so that's where those probabilities are coming from. You can see that we had a couple dirty orchards, and we went into these orchards on purpose with a disease history of fire blight, and you can see that where we had a high disease history or a high level of disease the previous year, we're finding it. We find it earlier. The disease cycle gets going faster than in these other orchards. A clean orchard generally starts out, we don't find it at mid-bloom. We may or may not find it right at full bloom, but then we tend to find it at petal fall. And there's a couple orchards here. You can see a couple here where we never found it at all in any walks. You can see some orchards here from Milton Freewater, Walla Walla Valley in Oregon, where we don't find it at mid-bloom. We find it in a few at full bloom, and we're finding it in quite a few more at petal fall. So this is kind of the typical pattern that we see, is that we start out low in mid-bloom, and as we get to petal fall, we generally find it. I would say the majority of orchards, we find it by the time we get to petal fall. All right. So I should say now, so we have that data. We have some idea about the probability of when we can find fire blight pathogen in orchards, and if the orchard has a high disease history, we can find it early. But if the orchard starts out clean, we don't find it till very late. But I would say that generally we find it in 1 or 2 samples from most orchards by the time we get to petal fall. So we've been using this LAMP scouting technique to re-examine the value of delayed dormant copper for fire blight control. And we've been doing this with Rachel Elkin. She's down in that lower left there, and anybody that has been around fruit for very long, apples and pears anyway, probably gets to know Rachel, and she's down there smiling, and most of the time she is smiling, and she's a great person to work with. So she's a great collaborator. And a couple of years ago, Rachel came to me and said, you know, that LAMP thing is pretty interesting, Ken. Why don't we look at this, the old practice of putting on delayed dormant copper and what value that has, and then monitoring that with LAMP. And so we've had a study going on in a couple of years now in California pear orchards, Bartlett pear orchards primarily. And we've been doing it for 2 years, and in the last 2 years we've split about 14 blocks, and there's roughly 10-acre blocks, so these would be 5-acre blocks each, and on half of the blocks we're putting on copper as delayed dormant. Green tip is what Rachel says sometimes, and then on the other half we're only putting on oil. And I think I've got a typo there. I've got 4 pounds per acre, but most of our treatments have been 6 pounds per acre. Rachel and I talk about this quite a bit, whether it should be 4 pounds or 6 pounds. Down where Rachel is, they're a little bit wetter in early bloom, and 6 pounds may be appropriate. I think in some drier areas, I think a lighter amount of copper would probably be just as appropriate. 4 to 6 pounds, depending on how much rain you're going to expect to get on at just prior to bloom. Okay, so here is the data for this for the last couple of years. Now here, just to go through this again, the overall probability of detection in this results for 2 years again, for this would be for the blue arrows here in the graph, 16% of the walks have resulted in detection of the fire blight pathogen. All right, at mid-bloom, early bloom, we're seeing less than 5% of the samples have been positive. But by the time we get to petal fall, we're up over half the samples are positive. So we've got the little epiphytic phase turning its cycle there, and by the end of petal fall, we're getting it so that the fire blight pathogen has become fairly common in the orchard. So you can see here in these graphs, this is 2 years of data. We've averaged in all the walks here. So there's about 30 to 40 walks in each of these data points here. So early bloom, it's hard to find the fire blight pathogen. In full bloom in 2010, we couldn't hardly find it at all. We get to petal fall, we're starting to pick it up. And we get to late petal fall, it's in basically all the walks at that point. And in 2011, you see the same thing. We're starting to pick it up in full bloom, and by the time we get to petal fall, we're in about 70% of the walks, we're picking it up. You can see the effect of the delayed dormant copper here, and the delayed dormant copper is slowing down the initial amount of cells that start that epiphytic phase, and so we're getting cycles turned at the same speed, but we're starting with fewer cells. That the sanitation effect of the copper is resulting in fewer cells being initially deposited in flowers to start the floral epiphytic phase, and we're getting a delay in the curve. So this, in plant pathology, we call this a classic sanitation effect. So the copper on the surface of the trees as a delayed dormant is slowing the rate at which the bacterial cells of the pathogen are making the jump into the flowers and starting this floral epiphytic phase. So you can see we've gotten pretty consistent results that the copper has slowed the rate at which we can detect the fire blight pathogen and pushes it out later into the bloom period. And same thing in 2011 under copper. Under the copper-treated blocks, we couldn't find it at full bloom, but we're starting to pick it up at petal fall. So Rachel and Steve Lindo have also been obtaining fruit finish data from all these plots, and it's a lot of plots in 2 years. And so far, Rachel has not been able to show a level of a different level of russet between the copper and oil and the oil alone. So there's been no effect of the delayed dormant copper treatment on fruit finish in these studies in 2 years so far. So so we're pretty positive about this. At least positive is part of putting it into an integrated program for fire blight control. All right. So just some summary on this first part here. When is the fire blight pathogen active in orchards? Well, it depends on the orchard, and I guess it should say it probably depends more on the disease history, but late petal fall is more the norm. That an orchard that is clean from last year generally will not show the pathogen being detectable in flowers until you're getting out fairly late between full bloom and petal fall. Does delayed dormant copper affect pathogen activity? Yes, it delays the time to when the pathogen is detectable. And that's a good thing, especially if we're going to be using these softer products. It gives us more time to build biological populations in flowers. And if we can slow down the pathogen, then that allows us more time to get these biological populations up to numbers that are useful for control. And then finally, I get asked this quite a bit, can I get lamp scouting done in my orchard? And I would say right now it's more of a research tool because it still requires a bit of skill, and I'm lucky to have a very good technician that has this skill with pipetting and DNA extraction. But this is all rapidly changing. There's about 6 companies in the world now trying to bring lamp assays to a practical place, and that they can be used for in-field or near site type applications. And the pictures down here are of a young man in Switzerland, Andreas Buhlmann, who works for Swiss Research Service, Ag Research Service. And he's out in the field using one of these new technologies, these new machines that do lamp, and he's doing lamp right in the field. And so these things, this is technology we're continuing to evaluate. So we're hoping that we can get this technology out into the fruit districts and make it simpler to use and easier to use, so that it at least can be used for some levels of fire blight monitoring in districts, and people can get then a better idea of timing of products and things like that for fire blight control. I wrote Andreas an email and I asked him, Andreas, you're doing that out in the field. Would would it be easier to do it at a kitchen table, you know, or in the shop? And he said, yeah, probably, but it wouldn't make as good a picture. So he's out in there in the meadow next to the field doing it, but it would probably be simpler to actually do it at least in a pickup truck, perhaps. All right. So here's a chance now. You got this little box. You can type some questions. So think about your questions on LAMP scouting, molecular scouting, we sometimes call it, and on delayed dormant copper. And then we can come back to it at the end. All right. So these are questions on these two topics right here. All right. We'll move on to bloom thinning, and bloom thinning is, you know, in commercial fruit is very important for getting fruit size, and in organics and more and more in conventional, lime sulfur is becoming one of the primary products to use for bloom thinning. And as most of you know, lime sulfur is also a fairly effective fungicide, and if you're working on scab control in wet climates, you're probably using lime sulfur for scab control. Now, lime sulfur is a good bloom thinner as well, and I would say that in organic production in the West, it's the primary bloom thinning agent. And this treatment here of 2% lime sulfur plus 2% fish oil is one of the more common bloom thinning treatments. And the typical protocol is, this is in apples now, king bloom open, 20 to 30% bloom would be the first treatment, and then followed in 3 days with a second treatment, which is typically 70 to 80% bloom. And then perhaps in some cases, if you had a lot of younger branches that had flowers that were opening at the tips a little bit later, there might be another treatment that goes on, and you'll see protocols that will say put it on the top half of the tree only, or something like that, to catch those late openers. But the primary treatment is about 20-30% bloom. It's the first treatment, followed at 70-80% bloom is the second treatment. And so lime sulfur is, like I say, pretty tough stuff. And if you put like biologicals or even many chemicals in the tank with lime sulfur, you're probably going to make a mess of them because it's so reactive. So in general, we don't think that lime sulfur is compatible in tank mix with any other fire blight products. So given that, it begs the question is, like, if I have to do bloom thinning, and you generally have to do bloom thinning, how do I then work my fire blight control around this practice? All right. So in replicated orchard trials, and I've got several of these figures. So these are my blocks that I have here at Oregon State. Golden Delicious and Gala are the two primary ones in apples. We've been just looking at the effect of what is the effect of lime sulfur and fish oil on fire blight. And these are inoculated trials, so at full bloom we actually go in and put the fire blight pathogen on. So we start this off, we do the 2 lime sulfur and fish oil treatments, and then we come in at full bloom and we inoculate. And so you don't see terrific control of fire blight here from lime sulfur and fish oil, but you do see some control. So we're going from essentially about 130 strikes in this experiment down to about 58. And this one here is 180 strikes to about 85, and the same thing over here, 200 strikes to about 120. So lime sulfur and fish oil is having an effect on fire blight. What do I think the effect is? Well, I think the effect is primarily is fewer flowers. So we're burning out stigmas when we put this stuff on. So we put lime sulfur and fish oil on, we're burning out stigmas, and the stigmas then aren't available to grow the epiphytic cells of the fire blight pathogen. So if I just said, you'd ask me what's the main effect of lime sulfur and fish oil? Well, it burns out stigmas and gives the fire blight pathogen no place to grow. All right. But if for the flowers that survive or the stigmas that it was on, lime sulfur is also toxic to epiphytic pathogen cells, and it's also toxic to epiphytic biologicals. So this will come clear in a second that we're really recommending that you don't start fire blight control programs until after you're done bloom thinning, at least after the second treatment with lime sulfur. And this is kind of speculation on my part, but after spraying lime sulfur and fish oil a couple times, and you look at your orchard after you're done, and you take a big whiff of the air, you realize that you've kind of created a stinky looking mess. And lime sulfur and fish oil, I can't believe this not being true, but I have absolutely no data to say it's true. But I do believe that lime, sulfur, and fish oil probably makes an orchard, after it's put on, somewhat less attractive to bees. And if there's a fewer bees in after you've got your fruit that you want, and now you're thinning and you don't want fruit anymore, and the orchard becomes somewhat less attractive to bees, you're probably, again, slowing down that epiphytic cycle that happens out there, and you get less flower-to-flower spread of the fire blight pathogen. So those three things I think are all going on from this treatment. Okay, so this is the same graph now, so that the data from the same slide was Gala, Golden Delicious, and now, and so we got water down here, lime, sulfur, and fish oil here, and now we're coming in after the lime, sulfur, and fish oil with this Blossom Protect product, and this is the new yeast product. And we've done some measurements on how this thing grows on flowers, and it really likes flowers, and it grows on stigmas to some degree, but it really grows in the nectary. And it really loves the nectary, and it makes what we would call a biofilm of yeast cells down in the nectary. We get really good colonization of the nectary with this yeast product. And you can see that so that when we put the lime, sulfur, and fish oil on, we get some degree of control, but then we come in with 2 applications of Blossom Protect, and now we're getting control, which is the yellow bars here, that's equivalent to streptomycin. And this is really a fantastic level of control, and probably some of the best control anybody's ever seen with biological products for fire blight control. So, and this is compared then to our integrated control, which would be bloom time and oxytet, and that gives us pretty good control, and also control compared to streptomycin. So this is a very good treatment. And so what we think about lime, sulfur, and fish oil and bloom thinning is that it shortens the period when fire blight products are needed. So, so we've gone in now in early bloom. We put on lime, sulfur at 70 and at 20 and 70% bloom, and we start the fire blight program after we're done with that second bloom thinning, and we've got a much shorter period now where we have to protect the flowers, and we have most of the flowers open so that our biological lands on the flowers and it can start to colonize. And at this point, especially at the full bloom timing, the pathogen populations are still fairly low in the orchard based on lamb surveys and based on what we think the lime sulfur is doing to any pathogen populations that got an early start. So the protocol here to get this was, 20 and 70% bloom, lime, sulfur, fish oil, then full bloom and petal fall are these fire blight products. And so we have a shorter period of time where we really have to be worrying about fire blight control. All right. So how does bloom thinning affect fire blight control? Well, we think that lime, sulfur, and fish oil shortens the period when fire blight products are needed. And we've done some work trying to sandwich fire blight products like Bloom Time Biological and Blossom Protect in between lime, sulfur, and fish oil. And what we found is that we tend to hurt the biologicals by sandwiching them between bloom thinning products. So our recommendation is really just do this, do the bloom thinning, and then wait until that's done, and then start with fire blight control. And it doesn't have to be a very long time. The effective residual of lime sulfur in the orchard is probably on the order of hours. After it's dry, it's pretty well used up its stuff. It doesn't have a long residual, very short. It doesn't have any punch left after a very short period of time. So when we say you can start fire blight products right after the second bloom thing, that means pretty much right after, even within the same day, is probably fine. Lime, sulfur, and fish oil is only one type of bloom thinning, and there's other types, and people will use various things. Lime sulfur alone at various rates of 3, 6, 9, 12%. So we don't have any data on just the effects of lime sulfur alone, but we're going to collect that this year. And another bloom thinner that is not organic but is used commonly is ammonium thiosulfate, and we're going to also collect data on that this year too, and look at that. Its effects on microbial populations in flowers. All right. So here's the next thing: questions about bloom thinning. There's a little box there you can add on there. All right. So last topic: can effective antibiotic control be achieved? And so I want to go over this integrated control concept one more time. And the idea is, and we're trying to get this concept out there to people, that there are really two phases of fire blight control. And one is the protection of the stigma, which I've got here in the red circle here. And that's where this floral epiphytic phase happens. And the pathogen is growing and spreading flower to flower, and the bees come in and move it from flower to flower. So that's one phase of fire blight control. And the other phase is protection of the nectary. Right? So back in the day when streptomycin was so effective, we could fill this nectary with streptomycin and we didn't really have to worry about this phase so much. If we go to non-antibiotic control, I think we have to worry about this phase more, and that means doing something early in bloom. And it could be as simple as putting on bloom thinners, or the other approach would be to put on these gram-negative bacterial products like bloom time biological or Blight Band 8506. And they go on there, they're going to colonize those stigmas, and they're going to slow down pathogen growth on those stigmas, all right? And then, but they're not standalone products, and that means that we have to come in with something to fill the nectary to prevent infection. And that could be Blossom Protect, or it could be Serenade Max, or it could be one of these copper and organic acid products that we could see here in a couple of years. So that's what I mean by integrated control, is like that we put on products early that target the stigma and the pathogen buildup in the flowers, and then we put on products late that are going to prevent infection when the pathogen slides down that style and goes into the floral cup where infection occurs. So examples of this would be antibiotic approach, bloom time biological, then Oxytet. And like I said before, working with Virginia, we found we got better control of fire blight with this program than we did with 2 applications of Oxytet by itself, or 2 applications of bloom time biological by itself. So this one here was targeting the stigma, and this one here is targeting the nectary. So the non-antibiotic approach to this that we've been looking at, and so we've already talked about lime, sulfur, and fish oil as an early bloom stigma burner, then coming in with the yeast product, Blossom Protect. And another approach would be bloom time biological, where we're not doing bloom thinning, so this would be maybe for pears, and then coming in with Serenade Max or Blossom Protect or some combination of that. So that would be what I'm talking about. And I've got a little bit of data on that. This is things we're going to continue to work on here. So again, same slide that we just had. This is that lime, sulfur, and fish oil with Blossom Protect. Excellent control. That one should be in everybody's mind right now. Another one we've been looking at is just say Blight Band then Serenade, or Bloom Time then Serenade. And the thing is here that this program works, but if we only put it on, say, 1 Bloom Time and 1 Serenade, or 2 Bloom Times, or one Blight Band and 1 Serenade, we only get sort of partial control, and the control is unsatisfactory, right? So, but if we double down on the treatments, and this means running the sprayer more often, and it means increasing the cost, but if we put on 2 Blight Bands, then 2 Serenades, or 2 Bloom Times, then 2 Serenades, we're getting control down to levels that are approaching what we would like to see as in commercial orchards. So again, these are inoculated trials, so we're getting a lot of strikes here. But if we're starting off, we're colonizing those stigmas with Bloom Time, and then we're hitting them with Serenade twice during that full bloom petal fall period, and we're getting pretty good control. And not as good a control as the Bloom Time than Oxytet, but still pretty high level of control. And this program has been used up in Central Washington the last couple of years for what's called the international program, or the non-antibiotic program, where fruit is being grown to be exported to the EU under the EU organic standard. So we've been recommending this program for a few years, and people have said that it works pretty well. So there's other things we can do to this program, and one of these is that we've been trying to figure out how to use this material, regalia. And so we're going to take this program of Bloom Time and Serenade and slip some regalia in there and see if we can continue to improve on control. We could also be slipping some Blossom Protect in there as well, and we think we can improve on control. All right. Back to Blossom Protect for just a second. Blossom Protect is this new yeast material. It's Basidium pollians, which is a filamentous yeast. It's a very common organism. It grows on a lot of flowers. In fact, many of you probably have it without even spraying the material. You could probably find Basidium pollians growing on your flowers in your orchard. Back in the day, I had this student that looked at what all the organisms were growing on cherry flowers, and one of the most common flowers to find was this, or common microbes or fungi to find on flowers was this Basidium pollians. And so Stefan Kuhns in Germany, he's the inventor of the Blossom Protect product, and the person that was working with Basidium pollians a few years ago, and he went out and he tried it for fire blight control, and he got the really good control of fire blight. But he's also found that with Basidium pollians, there's a slight increase in the risk of fruit russet from this organism. And so that's a little bit of a drawback for Blossom Protect. So that it's a little bit of a warning that don't go just whole hog into this stuff. And where he has found his problem is when he puts it on more than 2 times. So this one here, where I've got the red circle, Stefan put it on 3 times. The next one over, he put it on 4 times, and then the next one over, he put it on 3 times. And he bumped up the russet index in his apple crop with multiple applications. But where he's only put it on twice, he hasn't bumped up his russet index compared to the untreated. So we think that 2 applications of Blossom Protect are going to be safe in most places in the West anyway. And of course, the other thing is water, and fungi like water, so it also depends on how wet your fruit are going to get, particularly in late bloom and in the period after petal fall, how wet the fruit get, and as to whether or not we're going to have a problem with this. But for most of our drier areas, especially in Washington State, we don't think that those conditions are going to exist. And the company, I've talked to the company officials, and they're reasonably confident that we're not going to see russet problems from Blossom Protect in the semi-arid production areas, at least in Washington State. Some areas like, say, Anjos in Hood River, I'd be a little bit more cautious with it. Anjos are easy to russet, and Hood River is a little bit wetter, and so I'd be a little bit more cautious with this product. But we're going to try to do a couple trials of that area this year, and just single tree trials, so you can look at this a little bit more closely on pears this coming year. So I'm just about done here. So non-antibiotic control, we're talking about organic control without antibiotics, and so the question is can effective non-antibiotic control be achieved? And you know, now they've been working on this. This is about 2-3 years we've been working on this, and we've got another 2-3 years to go. That we're fairly optimistic that at least in the West here that using integrated control that we can achieve fire blight control without using antibiotics in organic orchards. So what's it going to involve? Well, I think it should involve utilizing delayed dormant sanitation and very thorough orchard sanitation in the first place. You know, being just meticulous about sanitation will really helps improve fire blight control. In apples, bloom thinning, especially with lime sulfur products, we think will delay pathogen buildup in flowers, and we're going to continue to collect more data on this. It certainly also is taking flowers out, and it's contributing to control that way. And it is also shortening the period that we think fire blight products are actually needed. So you get your bloom thinning done, then worry about fire blight control. In pear, using bacterial stigma colonizers to further delay pathogen buildup. If we're going to go to a non-antibiotic approach in pears, I think that this is essential, and I think it's going to be a really important part of control, and that we have to get these bacteria established on the flowers. And getting them established is key, because once you get them established, they kind of take off and grow on their own. Getting them established is key, and it's going to mean perhaps slowing down a little bit, maybe a little higher volumes of water. That you kind of have to get those flowers wet, at least for that period, to get those bacteria on there. But if we can get them on there and get them growing, then they really compete with the fire blight pathogen in that epiphytic phase, and they do some good. And then finally, utilizing blossom or Max, or maybe one of these copper and organic acid products well, this is the step that stimulates antibiotics. We think antibiotics do most of their work. It's full of the late bloom period, and they protect it from infection. So we have to get this yeast on, or we have to get multiple applications of Serenade on, or perhaps these other materials to get control. But if we do all those things, we can get good control. But the caveat to all of this is compared to antibiotics, especially compared to the old days with streptomycin, that treatments are increased, and therefore the cost will be somewhat higher. All right, and I think I'm going to end there and open it up for questions. I got a couple things to say here. First of all, my email is here. If anybody has a question they want to ask me, there's my email. I'm happy to receive emails to answer questions about this topic and then send them along. Plus, we have a lot of sponsors of our research, and of course, we have eOrganic, who's doing the work here today, along with E Extension, on our grant, our Organic Research and Education Initiative grant. It's Oregon State, it's University of California, and it's Washington State. So that's myself at OSU and Rachel at UC and Tim Smith at WSU. And support we get from growers is extremely important, and they've gotten us started on this stuff before we get the NIFA grant. So Washington Tree Fruit Research Commission is extremely important to my program and to Tim's program, and California Pear is extremely important to Rachel's program, and then USA Pear is also important, has been important to my program. And then finally, the funding that we're under right now to do all this work comes from USDA NIFA, and they're allowing us, pretty good resources at this point to get into this stuff at a pretty good rate. So I'm going to open it up to questions. Remember, we talked about lamp scouting, we talked about delayed dormant copper, we talked about bloom thinning, and we talked about this integrated non-antibiotic control. So just shoot your questions, and I'm happy to answer.
Okay, thank you very much, Ken. I just wanted to also say that Ken had wanted to ask you a couple of questions as well. He wanted to find out how many people in the audience were organic growers. So I'm just going to pop up two quick polls very quickly. The first one is, if you are a grower, is your farm certified organic? Is it conventional? Is it mixed? Or if you're not a grower, you can check that off as well. I'm just going to keep this up for about 20 seconds or so, and then I'll move on to the next one so that we can go on to the question and answer period. I can show the results for everyone as well. So we'll just leave this up for a couple seconds. Okay, here we go. So I'll just share the results of that. Okay. So we see we have 19% certified organic growers in the audience here and 12% conventional growers. Okay, and so then I'm going to just launch the second one. And this is for the growers in the audience about whether or not you might try the yeast product that Ken mentioned. So if you can fill that one out. Let's see, that one doesn't seem to have worked properly. Okay, let's see if we can do that. Okay, well, it doesn't seem to be working properly, but sorry about that, Ken. I can see if
That's all right.
While you're answering the question, I'll see if I can pull up another one. But why don't you get started while I do that? Some people wanted to know what LAMP stands for, and if you could just explain what that is.
Yeah. LAMP is like a PCR, which is a polymerase chain reaction. So in polymerase chain reaction, you put little primers of DNA that are sort of like keys to what you're looking for. So we would put keys in that are unique to the fire blight pathogen. So these are DNA keys. So in PCR, I think everybody's heard about PCR, you make a lot of copies of what you're looking for, the target DNA. With LAMP's a little different in that it's like PCR, so you make a lot of copies of the target DNA. You put primers in there, and the primers actually look for the pathogen DNA. The advantage of LAMP over PCR is that it just works at one temperature. So it runs at 65 Celsius, which is about 135 Fahrenheit. And you don't have to have a fancy machine that cycles the temperature up and down. And so that makes it really easy. And one of our joke names for LAMP, and LAMP stands for loop-mediated isothermal. Isothermal means one temperature. Loop-mediated isothermal amplification of DNA. So that's what LAMP stands for. And you know, it's a big, long, you know, thing. So don't say that very often. One of our joke names for LAMP is coffee cup PCR because it just runs at the temperature of a warm cup of coffee, essentially. So it's really simple to do, and the technology that's coming out is making it easier, and so that we're not really quite sure it's ready for, say, an on-farm, that every individual farmer would be able to do LAMP, but certainly somebody in a fruit district could set up a service to sample the flowers, or the growers could get the flowers themselves and take it to, say, you know, a Western Farm or Wilbur Ellis or somebody like that could, say, even just get a college kid, you know, that's got a little training in biochemistry, and not that much, but they could do it and provide it as a service, and we were trying to get it to that point.
Okay, thanks. Here's a question about copper, whether you need to use oil with the copper or whether you can use copper by itself.
Yeah, I would say you can use copper by itself, and the reason that the oil is in there is that the oil is a standard treatment for going after eggs of mites and pear scilla and things like that, and so the typical treatment, at least by Western orchardists, is at the delayed dormant timing you want to put on oil, but if you also want to put on copper, and it is safe to mix them together. So that's been our treatment, to put on copper and oil together, but you could just put on copper by itself and it would have the same effect.
Okay, here's a question about lime sulfur. As lime sulfur's primary effect is few flowers, how does it affect the overall yield?
Now we're talking about bloom thinning, and I would have to say that I'm still on the learning curve about bloom thinning. As I'm sure there's some people probably chuckling out there right now listening to Ken answer this question. As you know, in fruit production, size is everything, and the goal is to thin the fruit so that you get big fruit, but that you don't reduce the number of bins you get bigger. So that's that goal, and there's also a level of art in bloom thinning, and there are some farm advisors perhaps listening that are actually very good at bloom thinning, and they know this art part of it better than just the standard recommendations, and they will probably have stories about whether or not they always get the same yield, whether they thinned or not, but they would still say that it's essential to do bloom thinning if you want to have fruit that has high value, and fruit that, and basically the definition of fruit that has high value is clean fruit, doesn't have any marks, but also that it's big. So the thinning process gives you more big fruit, and that's why it's so important.
Okay, thanks. Meanwhile, I've gotten that poll question set up again, so I'm going to pull up that poll again. So Ken would be very interested to know that if you are a grower advisor, if you could type in whether or not you plan to try the yeast products. So I'll just keep this up for another, 15 seconds or so, and then we'll move on to more questions. Okay, thank you very much for filling that out. Another 10 seconds or so, and we'll take it off.
You're a little crackly there, Alice.
Okay, sorry about that. Can you hear me?
Yeah, now I can hear you.
Okay, great. Okay, next question. How delayed can the delayed dormant copper be with respect to bloom stage?
Did you get the answer there, Alice? I can't see the answer on my screen.
Oh, okay. I'll share it with you. Let's see. Let's see. There it is. You see it?
No, I just see a little pink arrow that says sharing poll results, but do I have to click on that?
Well, I can show it to you afterwards, but it basically says 47% do plan to try the yeast product, 8% said no, and 45% said maybe of the people.
Okay, yeah. You know, I do think that we need to have some practice with this stuff, and we've got a couple years of practice here, and I don't know, say, when it comes down to what these industry petitions, I don't think anybody knows in terms of keeping antibiotics on the NOP list. I don't know if anybody can predict the outcome at that point. So I would say go out there and get yourself at least on a trial basis, some part of the orchard. We got to get some practice with this material. All right.
Okay. Here's a question about whether or not you use copper on the cankers.
You know, if you could go out and paint every canker with copper, say if you could get an old-fashioned Bordeaux mixture and paint every canker, it would probably help to keep those cells from making the jump. The problem is that it's usually, you know, it's been around fire blight long enough, and people talk about, yeah, I got every canker out of my orchard, or I treated every canker in my orchard, and I still had a problem because I had the disease last year. It's just that you just don't get all of them, and you can't see them. Some of them are so small that you're going to miss them. And so that's the issue of why a spray is more effective than, say, going out and painting. But certainly if you could find every one of them and paint them or cut them out, you would achieve sanitation that way too.
Okay. Here's a question about the yeast, whether it outcompetes blight bacteria for the occupation of nectar. Let's see, I can't quite see that whole question, so I'm not sure if I asked it correctly.
Well, I think, I don't think that the yeast itself is very toxic to the fire blight pathogen. We're not aware of it, say, making any of its own natural antibiotic components that inhibit the ability of the fire blight pathogen to grow. If you pair them up on a petri dish, you put the yeast in the middle, and then say, spot the fire blight pathogen around, I don't think you'd see any inhibition of the due to something leaking out of the yeast. Yeast and biocontrol have had fairly significant history in, say, control of post-harvest fruit rots, and so if you dip a fruit with yeast right at picking or shortly after it gets on the packing line, you can get the yeast into the wounds of the fruit, and the yeast grows there and makes the fruit more resistant to things like botrytis or penicillium, blue mold, gray mold, those kinds of things. And it's thought that they just really are good at just taking all the nutrients out of the wound. And so without any real direct data, just speculation here, we think that it's probably the same thing goes on in the flower, that the yeast sitting down in the floral cup is basically consuming all the nutrients. And the floral cup is interesting. Nectar is interesting because there's a high kind of osmotic potential when it's first, it's sugary. And so it actually is inhibitory to bacterial growth that the sugar content is so high when the nectar first comes out. And it would be like having a jar of jelly. You don't see it in a jar of jelly. You don't see bacteria growing on the surface because the sugar content is so high osmotically. But if that nectar gets diluted a little bit with water, then it gets down to an osmotic pressure or a dilution factor that allows bacteria to grow. So there's not enough osmotic inhibition of bacteria. Yeasts, on the other hand, are not inhibited by these high osmotic potentials or pressures. So the solution can be really sugary and the yeast will still grow. And so the yeast has an advantage so that when you put the yeast into the nectar, it grows in that high osmotic nectar and will colonize and make that film there and use up all the nutrients. So when the little drop of water comes down with the bacteria after a dew event or a rain event into the nectar and the fire blight pathogens there, then the yeast is there, the biofilm is there, and it's not. I wouldn't say we completely understand this at this point, but the fire blight pathogen is unable to affect the flower at that point.
Okay, we have a couple of questions about mixing some of these different products. The first one is about whether or not you could mix Serenade and Blossom Protect to improve control, or would Serenade inhibit Blossom Protect?
That's a good question. I can't say we've done that yet. I think that you could probably mix them, but that's one thing we're going to have to look at in the next year or so here, and we'll probably look at it from a lab point of view this spring. Serenade is not the strongest material in the world, and it has a very short residual, and I doubt it really kills anything. I'm sure it just sort of prevents like spores from germinating, so that if you did put the yeast on with the Serenade, and the residual of Serenade is probably just a couple days, which is why we think you have to put it on more often. Why to get up to a level of, say, oxytetracycline with Serenade, you have to put on 2 treatments instead of 1. I'm just speculating here. I don't know the answer. It's an excellent question, and one that we're definitely going to look at. But mixed together, I mean, compared to, say, mixing Blossom Protect with lime sulfur or something like that, or even mixing Serenade with lime sulfur, which I wouldn't do, it might be a compatible strategy. It's just something we're going to have to look at.
Okay. Here's another mixing question. Let's see. What are your feelings? Well, not necessarily mixing, but using products in combination. What are your feelings on a Casamine Oxytet Regalia combination in conventional pears?
Calcium as the first treatment?
Casamine, it says.
Oh, calcimin.
Oh,
I
calcimin.
can't say I know. I don't know much about calcimin or calcium, whatever we're talking about. You know, calcium sprays are used for enhancing resistance in tree fruits a little bit more, but generally for post-harvest rots. I'm not that familiar with using calcium early in a bloom period for fire blight. I've never evaluated it. And the other part of the question was?
Oxytet and Regalia.
Oxytet, well, of course, Oxytet is a good material to use for fire blight control. And it works very well. We think it works better if we used it like I talked about in the seminar. Regalia, I don't know anything about. I've got an order to get some here, and we're going to put it in some trials. But there just is not a lot of data on Regalia showing how effective it is yet in inoculated fire blight trials. And that's about all I'm going to say about it. I know of a little bit of data, and I think it does some good. But I just don't know enough to confidently tell you how much good it's doing.
Okay. Does this research translate at all into the maritime conditions on the west side of the Cascades?
Yes, it could. The west of the Cascades, though, unless you're putting fire blight out there in the orchard like we are in our trials in Corvallis, fire blight usually isn't a real big problem. The bigger problems, of course, are apple scab and apple scab. So I think it translates. I think what we're talking about probably translates into various regions, though you might have to do some fine-tuning or adaptation in various regions. But in maritime, Western Oregon, Western Washington, generally fire blight is not a real big problem.
Okay, here's a question about whether the yeast products do anything to pollinators. It seems as if the nectar ferments in the flower, the honeybees might not be drawn to the flowers?
Boy, I don't know. Don't know the answer to that. Honeybees, I would say, in the springtime are primarily, they are going after nectar. And I just don't know the answer to that. A lot of things go on in the orchard, and we still get fruit set. And in fact, we're using thinners out there because we get too much fruit set. So I'm going to say that I don't know of any major effects of yeast in a nectary. I mean, a lot of flowers already do get yeast and nectaries just by chance from natural yeast. So I'm going to say that my guess would be that the impact is minimal, but I don't know definitively. I've never seen any real data on that.
Okay, we had a question on how late you can apply copper.
Well, we're using it as in the stuff that I put in the webinar. We're using it up to about green tip there, just short of cluster separation in pears. I don't know. I mean, if you get it onto the flowers, or if you get it into as the clusters are coming out and the individual fruitlets now are becoming apparent, then you've got this chance of enhancing the fruit finish or the russet condition on the fruit. So I'm going to say that keep it to a delayed dormant and not and then certainly not after first bloom. I mean, there are some situations where people do use copper during bloom. I know some situations down in California where fire blight is a very difficult problem to control, and they're using very dilute rates of copper during the bloom period for fire blight control. And if we get these copper and organic acid products, well, we'd be using those the same way during the bloom period. And the hope is that those products are going to be safe on fruit. But if we're just talking about fixed coppers like copper hydroxide or dough mixture, or there's a couple other ones, copper oxide is another one. Generally, we're saying to use those before you get a lot of cluster and flower buds out in the open.
Okay, this is a clarification of a previous question. The question was, what were your feelings on a Casamin, Oxytet, and Regalia combination? And Casamin would be the antibiotic Casamin.
Right. Mm-hmm. Okay. Casamin or Casumin, as I usually say it, is the antibiotic Casugamycin. It does not have a registration in the United States. It's very close to getting a registration in the United States. It does not have an organic approval, and it's probably unlikely to get an organic approval, just the way things are right now. So if we're talking about organics, Casumin is not going to be something that's allowed. And especially if we lose strep and Oxytet, I really don't see Casumin being allowed in organics because it is an antibiotic material. Casumin, we've done a lot of work with Casumin in conventional orchards and for conventional production, and we think it works very well. It works better than Oxytet, but probably doesn't work quite as well as streptomycin did in the old days before there was resistance. So we would be using it at timings like I showed in the seminar with a full bloom timing, and then if conditions got extreme with high temperatures, something close to petal full timing. It's a very good material. So in conventional, we're really hoping to see that product get registered.
Okay, we got a couple questions on fish oil. The first one is, any sense of the differences between the use of fish oil or regular oil when thinning with lime sulfur with respect to the effect on fire blight?
I don't have an answer to that question. We've gone with fish oil because it's an organic oil. Some oils are not organic, and therefore aren't allowable under the organic standards. Fish oil, there's a company up in Quincy, Washington called Crocker's Fish Oil, and they're very close to the apple production region. So most people that are using oil in thinning are using Crocker's Fish Oil. And in Washington State, about 10% of the apple acreage, which is about 20,000, let's say 18 to 20,000 acres, is organic now. So, and Crocker's has been the primary supplier of the oil that's used in thinning. That being said, not everybody uses oil, and some people will use just lime sulfur in thinning organic fruit, and then the rate of lime sulfur is higher, and the range of lime sulfur can be anywhere from, say, about 3% on the low end up to 10-12% on the high end. If you really had a heavy crop of flowers you were trying to take off, then they're going with these pretty high rates of lime sulfur. You get various opinions about this on what's the best way to thin, and there's a lot of people that have a lot of opinions, and like I said, there's art involved in bloom thinning. But some folks like Harold Austinson up in Wenatchee swears by lime sulfur and fish oil, that 2% treatment, and he's a big proponent of it, and we've had good success with in our blocks too. We're not really trying to grow quality fruit, but we certainly thin fruit, and we don't thin them all, and we get nice sized fruits on the ones that we thin.
Okay, yeah, and the second question on fish oil was if you could define exactly what that fish oil is as opposed to fish hydrolysate.
I can't. I just know it as Crocker's Fish Oil. You could call up the company. They're in Quincy, Washington, Crocker's, and you can ask them that question.
Okay. We have time for about 2 more questions or so. In orchards with a strong fire blight history, would an application of fire blight control materials prior to lime sulfur be an acceptable strategy?
Yeah, it might be. But I would certainly be using copper in those orchards as a delayed dormant. And those orchards where it jumped in really early, they tend to be later blooming orchards. So if you had an apple block sort of downwind or next to a pear block, so it's a situation of later blooming, and the fire blight pathogen had a chance to get going in the pears, maybe not to really hugely damaging levels, but then jumped into the apples. You could get started much more early in there just because of the bee flight between the two blocks. Another situation we see is at higher elevations, and I think pears tend to be at a little bit higher elevations than apples. But say the situation for us in Oregon is Parkdale, Oregon. Parkdale blooms, say, 2 to 3 weeks after the lower Hood River Valley, and then the upper Hood River Valley, which is Parkdale. They tend to bloom a little bit later, and then when they come into bloom, they often hit those temperature peaks in mid-May that raise their risk index. They've also had the bees out there for however long working in the valley, and maybe the fire blight pathogen has kind of worked its way up so that there's more of it around. And those are the blocks where we tend to see it in there a little bit earlier. So certainly in pears, you want to get onto it as early as you can. In apples, if you've had fire blight in there, I still think this is where we need to do more research and understand what we're getting out of lime sulfur in terms of how much suppression of the pathogen we're actually getting. Because in our trials now where we've been looking at lime sulfur, we've been inoculating the trees after we put the lime sulfur on, so that we don't ever hit the pathogen directly with lime sulfur. My feeling is, and what we're going to do this year, is we're going to go out and hit the pathogen directly with lime sulfur and see what happens. And my feeling is that lime sulfur itself is going to have some suppression effects on the fire blight.
Okay, and here's a question about the LAMP study. Were you able to positively identify the fire blight vector into the clean orchard in the LAMP study?
No, can't say we have. There's, as you probably know, that if you followed fire blight for a long time, there are numerous vectors of the fire blight pathogen, and probably the most common one that we talk about most of the time is the honeybee, because honeybees are put out there for pollination, and there's a body of literature that says, yeah, honeybees can move the fire blight pathogen around, but other people have washed various bugs they found in orchard and asked them to get the fire blight pathogen off those bugs, and in many cases on any insect that's visiting a flower and moving to another flower that had the fire blight pathogen on it and moving to a flower that didn't, they probably have a probability of vectoring the fire blight pathogen. I don't think it really matters what the insect is. All they have to do is have legs and a body that they could smear on a stigma and then go to another flower and smear their legs and body on that new flower, and they could probably move the fire blight pathogen that way. Generally, when we think about what's going on, what increases the flower-to-flower spread, we generally think it's bees, but native bees or other insects out there could probably do the same thing.
Okay, we're running out of time, but I just wanted to mention to everyone that this webinar has been recorded, and I just put a link in your chat box. And Ken, if you could just advance the slide one forward, people can see the link where they can find the recording.